Good evening, students. As we have completed exercise 10.3, we have discussed in Zoom class. So today we are going to start theorems of 10.4 exercise. Theorem 10.6 is equal chords of a circle are equidistant from the center. You have given a circle with center O and two chords AB and CD given which are equal. You have to prove the center of these chords from the center is equal, means OX is equal to OY. So firstly we write given circle with center O, AB is equal to CD. Now the distance of chord from center is perpendicular, OX perpendicular on AB and OY perpendicular on CD. And we have to prove OX is equal to OY. So now we will do its proof. Firstly see, we have done a theorem, I think 10.3 or 4 theorem we have done, that the perpendicular distance from the center on a chord bisects the chord. It means OX perpendicular on AB, that implies AX is equal to BX, that is half of AB, and similarly we can write CY is equal to DY, that is half of CD. Now we have given that AB is equal to CD. It means their half is also equal. It means AX is equal to CY. We have proved that this AX is equal to CY. Now we take these two triangles, triangles OAX and triangle ODY. In these two triangles, OA is equal to OD, that is radius. AX is equal to DY, we recently proved, and this angle OXA is equal to OYD, which is 90 degree. So these two triangles are congruent. If triangles are congruent, then we can take OX is equal to OY by CPCT. This was the result which we want to prove, that the chords, equal chords from the center are at equidistance. Okay. Now next theorem, theorem 10.7 is its converse. Here we have to prove that chords equidistant from the center are of equal length. If we have given two chords AB and CD and their distance from the center is equal, means OX is equal to OY, then we have to prove AB is equal to CD. So now let us see how to do. Firstly we write given AB and CD two chords of circle where OX is equidistant from center. So OX perpendicular on AB and OY perpendicular on CD. We have to prove AB is equal to CD. See its proof. We take firstly in triangle AOX and DOY. In these two triangles, angle OXA is equal to angle OYD, 90 degree. OA is equal to OD, radius of the circle. OX is equal to OY given. Okay. So by RHS we can congruent these two triangles, hypotenuse, side and 90 degree angle. So triangle AOX congruent to triangle DOY. If triangles are congruent, then we can take AX is equal to DY by CPCT. Now this is the distance and OX is perpendicular on AB. It means AB is twice of AX and CD is twice of DY. We can write here as AX is equal to DY. It means its twice is also equal. It means AB will be equal to CD. So this was our second theorem, that is converse of 10.6. Now we have given two results. If two chords are equal then the center from the distance from the center is also equal. And if we have given two chords are equidistant from the center, it means both chords are equal. Okay. So after that, exercise 10.4. This exercise you will try. If any doubt is there, then discuss with me in Zoom class. Here, as in first question, you have given the radius of the circles. Okay, you have to find length of common chord. So this question, for this question we will use these theorems and the examples. Okay, so try this. Any doubt is there, then clear with me in Zoom class. Okay, thank you students.